Imagine a world without your favorite tunes on the radio, without your mobile phone buzzing with messages, and without the internet connecting us all. It seems impossible, doesn't it? But all these things, and many more, are possible thanks to something we can't even see: radio waves. Radio waves are a type of electromagnetic radiation, just like the light we see with our eyes. But unlike light, we can't see radio waves. They are invisible messengers, carrying information through the air at the speed of light. From broadcasting our favorite songs to sending data wirelessly, radio waves play a crucial role in our modern world. But how do these invisible waves work? How were they discovered? And what are their properties? Join us as we unlock the fascinating world of radio waves and explore their profound impact on our lives. The story of radio waves begins with a Scottish physicist named James Clerk Maxwell. In the 1860s, Maxwell developed a set of equations that predicted the existence of electromagnetic waves. These waves, he theorized, could travel through space at the speed of light. Maxwell's theory was groundbreaking, but it wasn't until 1887 that his predictions were proven correct. A German physicist named Heinrich Hertz conducted a series of experiments that confirmed the existence of electromagnetic waves, including radio waves. Hertz's experiments were ingenious. He used a spark gap transmitter to generate radio waves and a loop antenna to detect them. Hertz's discovery paved the way for a revolution in communication. Within a few decades, inventors like Guglielmo Marconi would build upon Hertz's work, developing the first practical radio systems. These early pioneers recognized the immense potential of radio waves to connect people across vast distances. To understand how radio waves work, imagine throwing a pebble into a pond. The pebble creates ripples that spread outward from the point of impact. Radio waves behave similarly. They are disturbances in the electromagnetic field that travel outward from a source. But unlike water waves, which require a medium like water to travel, radio waves can travel through the vacuum of space. This is because they are self-propagating, meaning they carry their own energy as they travel. The speed of radio waves is incredibly fast, approximately 299,792,458 meters per second, which is the speed of light. This speed allows radio waves to travel vast distances in a fraction of a second. As radio waves travel, they oscillate, meaning their electric and magnetic fields vibrate back and forth. The distance between two consecutive peaks of a wave is called its wavelength, and the number of waves passing a point per second is called its frequency. These properties are key to understanding how radio waves are used in different applications. One of the most important uses of radio waves is in communication. Radios, televisions, mobile phones, and Wi-Fi all rely on radio waves to transmit information. But how does this work? Imagine you want to send a message to a friend far away. You could shout, but your voice wouldn't travel very far. Instead, you could use a radio transmitter. The transmitter converts your voice into radio waves, which are then sent out through an antenna. Your friend's radio receiver picks up these waves and converts them back into sound. Different frequencies of radio waves are used for different purposes. For example, AM radio uses lower frequencies than FM radio, which allows it to travel further but with lower sound quality. Mobile phones, on the other hand, use much higher frequencies, allowing for clearer calls but shorter ranges. Beyond the radio, exploring other applications of radio waves. While radio waves are best known for their role in communication, their applications extend far beyond our radios and televisions. In fact, radio waves play a vital role in numerous fields, from medicine to astronomy. In medicine, radio waves are used in magnetic resonance imaging, or MRI, to create detailed images of the inside of the human body. MRI machines use strong magnetic fields and radio waves to generate signals from water molecules in our tissues, allowing doctors to diagnose a wide range of conditions. Radiotherapy, another medical application, uses high-energy radio waves to destroy cancer cells. Astronomers use radio telescopes to study celestial objects that emit radio waves such as stars, galaxies, and black holes. These telescopes capture radio waves from space, providing us with valuable insights into the universe's mysteries. Radio waves are also essential for navigation, with systems like GPS relying on radio signals from satellites to determine our location on Earth. Pioneers of the airwaves, key figures in radio wave history. The story of radio waves is intertwined with the ingenuity of numerous scientists and inventors who made groundbreaking contributions to the field. Apart from James Clerk Maxwell and Heinrich Hertz, several other pioneers deserve recognition. Guglielmo Marconi, often hailed as the father of radio, is credited with developing the first practical radio system for wireless communication. His invention revolutionized communication, paving the way for the radio broadcasts we enjoy today. Nikola Tesla, a brilliant Serbian-American inventor, made significant contributions to the development of alternating current, or AC, electricity supply systems, which are crucial for generating radio waves. Jagadish Chandra Bose, an Indian physicist, made remarkable advancements in radio wave research. He demonstrated the wireless transmission of signals over short distances, and is credited with developing the first wireless detection device using a semiconductor junction. These pioneers, driven by their curiosity and innovation, laid the foundation for the ubiquitous use of radio waves in our modern world. Frequency matters, understanding its significance in the world of radio waves. Frequency plays a crucial role in the world of radio waves. It determines the characteristics of a radio wave and how it interacts with its surroundings. Measured in hertz, frequency represents the number of wave cycles passing a point per second. Different frequencies of radio waves have different properties, making them suitable for specific applications. Lower frequency waves, like those used in AM radio, have longer wavelengths and can travel further distances, even bending around obstacles like mountains. However, they are more susceptible to interference. Higher frequencies, like those used in FM radio and mobile phones, have shorter wavelengths and offer higher bandwidth, allowing for the transmission of more data. However, they have a shorter range and are easily blocked by objects. Understanding frequency is crucial for managing the use of radio waves. Different parts of the radio spectrum are allocated for specific purposes, from broadcasting to navigation and scientific research. This allocation ensures that different applications don't interfere with each other. Conclusion: radio waves and the future. From the early days of radio broadcasts to the wireless technology that permeates our modern lives, radio waves have transformed the way we communicate, access information, and interact with the world around us. Their impact on society is undeniable, connecting us across continents and expanding our understanding of the universe. As technology continues to advance, the role of radio waves is only set to grow. The development of 5G and future generations of wireless communication systems promises even faster speeds, lower latency, and more connected devices. Radio waves will continue to drive innovation in fields like telemedicine, autonomous vehicles, and the Internet of Things, creating a more interconnected and technologically advanced future. The invisible waves that were once a scientific mystery have become an indispensable part of our lives, shaping the world around us and holding the key to a future brimming with possibilities. As we continue to explore the full potential of radio waves, one thing is certain: these invisible messengers will continue to play a pivotal role in shaping the future of humanity.